Hi, Kinesiology 4120. Welcome to our lecture on landing mechanics and plyometric progressions. So today I'm going to talk about um, some of the variations for plyometric training, as well as some of the key focuses around landing mechanics, because landing mechanics are our keys to avoiding and hopefully limiting any injuries with our athletes, because most non-contact sports injuries occur during some landing or absorption of force. So we're going to talk about some of the keys for landing mechanics and how to progress those through our plyometric profile, all of the different variations we can use and how we can really get creative with this type of training. Okay. On top of that, I'm only going to focus on lower extremity plyometrics today. We're not going to talk about rotation or upper extremity plyometrics today. Okay, so the first thing I want to talk about is our universal athletic position. So if we think about all of the sports everybody has played, if we're looking at field sports, court sports, pretty much every sport we play has a very similar universal athletic position, which is this A-frame of the lower extremity. The toes are pointed forward. The knees are over the feet, not too far forward, not too far back, and we're really loading the posterior chain. If this is done correctly, we are truly loading the posterior chain, so the hamstrings, the glutes, the erectors, the calves, all of those posterior musculature in order to absorb force and then produce force. Okay, we see this in all different sports. We see it in baseball, football, basketball, tennis, wrestling, okay, even ping pong. Okay, we see the universal athletic position across all different sports. And this is the key move or the key setup because it allows us to move in any direction. It allows us to react and absorb force as well as produce force to move up, move forward, turn, to move to the side, move laterally, go forward, go backwards. However we need to move, we can go there from this position. We also train this universal athletic position within our strength training movements. So for example, a RDL, a power clean, a squat, a deadlift, we're always really trying to focus on training the posterior chain with our bilateral hinge or squat movement patterns, where we're loading the posterior chain and training it to absorb force and produce force so that we can safely move within our sport and effectively and efficiently move within our sport. So if we transition that to plyometrics, things like jumping, we load into the universal athletic position in order to jump. Okay, we also land or should land within the universal athletic position or the UAP. Okay, what happens when we land? We have to absorb force. We absorb our body weight that is accelerating towards the ground at the rate of negative 9.8 meters per second. So that is the rate of acceleration. So the higher you jump, the more force you're going to have to absorb based on your acceleration towards the ground. Your body's ability to maintain posture throughout the upper and lower, through the upper body and the lower extremity is going to be key to avoiding injury and optimizing our performance. So when we land, we want to land in the universal athletic position where it loads our posterior chain and we are ready to move now in another direction. We effectively use the large musculature of the hamstrings and the glutes to absorb that force to then redirect force in another location. If we have weakness of the hamstrings and the glutes, we may force the adductors and the quadriceps to take over that job around the hip and the knee. If we have weak ankles and feet, if we're not able to control our foot and ankle position, it's going to alter our knee position. And we'll see this kind of valgus or knee knocking, knee collapse from poor ankle and foot posture, or from poor hip mechanics because we have to recruit musculature that may be suboptimal in absorbing force. Adductor magnus is a large hip extensor, but it's going to pull us in towards the midline rather than gluteus maximus, which is going to pull us towards the outside. And the hamstrings are going to keep us in the middle and stabilize the knee. If we have to use the quadriceps, it's likely, if the quadriceps are the primary force absorber, we're often going to keep a very upright torso. We're likely not going to be able to load the posterior chain well, and we're going to see this knee collapse towards the midline, which is one of our risk factors. If we land like that, it is a risk factor for ACL injuries, which is a very common injury that comes from non-contact, poor landing mechanics. So we see this valgus position within the takeoff. That could be an indicator because we're recruiting different musculature to achieve the goal of jumping. We're now recruiting maybe the adductor musculature, maybe we're forcing the quadricep musculature, rather than loading up the posterior chain, the glutes and the hamstrings to really drive that force production. Our external rotators may be weak and our internal rotators and our adductors are very strong, bringing our legs towards the midline rather than keeping them in a straight line of force through our feet, which can lead to major injuries. So we have to remember our universal athletic position. We have to cue our universal athletic position and make sure that it's a constant throughout our plyometric progressions. Our primary plyometric progressions will start, I'll take you through some videos, but they all come back to a stick in the universal athletic position so that we can ingrain that movement pattern within our athletes. So the first one is toes to stick. So this is where the athlete moves up onto their toes and drops into the universal athletic position. This is the lowest load. It's the slowest moving, and it's forcing us to ingrain this universal athletic position. We transition that into a counter movement jump to stick. So now the athlete is loading into the universal athletic position, jumping, and then landing back in that position. Okay, every time I say stick, I mean land and stay in the universal athletic position. Okay, and then we can progress the counter movement jump higher and higher and higher to increase the stress on the athlete. We then have the drop to stick. The drop to stick, we are going off of some object, so maybe a box, and we are landing and sticking in the universal athletic position. But now we are landing from an external height. So now we have to prepare and organize ourselves from a height that we do not already know that we're moving, because our counter movement jump, we can put ourselves within a height that's safe for us, and we understand that we can land. From a drop, we can increase that height beyond what we could normally jump on our own. Then we can move into repeated counter movement jumps. So now we have to load the athletic position, jump, so produce force, absorb force, and then reproduce force. This is where we really move into true plyometrics, where we're repeating these counter movement jumps. So maybe we're doing 3 jumps and we end in a stick. We're cueing throughout that time to use the universal athletic position to load and then explode out of that position. And lastly, we have a drop jump to stick. So this is where we are falling from a height, landing and immediately performing a jump and then landing in a stick. We can also add repeated counter movement jumps on top of that. We can jump, stick, and we can add stress through volume, or we can add stress through intensity of height, different variations of jumping. But this is our basic plyometric progression for a bilateral hinge plyometric exercise. We can go into unilaterals a little bit later, but these are kind of our basics. This is where you should start. So I'll give you some example videos. Okay, we have toes to stick. So we're going from a up on our toes position, and then we stick in the universal athletic position. Okay, so bring it back. We'll watch it again. Up onto the toes, universal athletic position. Up onto the toes, universal athletic position. Okay. Now we can move to the counter movement jump and stick. The intensity of the jump is going to dictate the intensity of the exercise. So the higher you jump, the more stress it's going to place on the athlete. So a short jump, athletic position. Jump, athletic position. Small jump, athletic position. Next, we'll move to the drop to stick. Okay, so here we are going from some external height. Here I have about a 10-inch, 12-inch box. Drop and stick in the universal athletic position. Land, hold that position. Force the athletes to hold that position so that you can begin cueing and correcting any faults they may have. Drop and stick. Make sure you're viewing from frontal and from sagittal viewpoints so that you can see ankle position, knee position, hip position, as well as frontal plane, hip, ankle, and knee position. Lastly, we'll do a drop jump to stick. I'm not going to show repeated counter movement jumps. It's just on top of a regular counter movement jump, and you're just progressing it. So we have our drop jump to stick. We drop off of the box, land, jump, and then finish in our universal athletic position. Drop, jump, and stick. Okay, same for the sagittal view, drop, jump, and stick. Okay, hopefully you were watching and paying attention to these mechanics. So I added in some technical errors that hopefully you noticed. So if you didn't notice any, rewind, watch through again, and see if you can find those technical errors. All right, if you haven't rewinded, stop, do your due diligence, go back, rewind, see if you can make some notes on some technical errors. All right, now we'll go through them individually. So the first one was a toes forward position. Was it there? Okay, my right foot had a slight toe out compared to my left foot. My jumping mechanics had a slight toe out compared to the true universal athletic position, which could be a compensation pattern for myself of using a greater quadricep pattern rather than posterior chain pattern to achieve those jumps. So that could be something to cue. If your athlete has a toe out position, make sure that you're reaffirming, hey, let's bring him back into a forward position. If the toes are out, we lose the ability to move well in other planes of motion. So we have to cue that and make that a normal, comfortable position. Okay. You may also see that I was more quad heavy or knee dominant compared to posterior chain dominant on my landing and jumping. This could be from a running and weightlifting background, Olympic weightlifting background, which is a very quad dominant activity, a very quad dominant pattern within the pull and within the lift. So cueing and training more posterior chain dominant exercises and practicing jumping and landing using more posterior chain strategy could improve jumping and landing safety and ability. There's also inconsistent landing. So foot width and foot position anterior to posterior was different from jump to jump. So this could be inconsistencies in how I'm producing force, how I'm landing, could be from my toe out position. But this is something to watch. Are the athletes' landings repeatable? Can they repeat that universal athletic position? And can they repeat it correctly? Just because it's repeatable, if it's incorrect but repeatable, we still need to correct that error, because whatever they do in the most stressful point in training, they're going to be even worse when they go out on the field, because now they have other external stressors. So we have to keep what we can control and control it as well as possible, so that our athletes are going to use those strategies out on the field or the court. All right, now we'll transition into some multiplanar plyometric examples. The first one, we think of our sagittal plane plyometrics. We have vertical and horizontal sagittal plane plyometrics. We have vertical jump and moving the body vertically away from the ground, and we have horizontal jumps moving as far likely forward or jumping backwards as possible, and combinations of those, like a hurdle jump, you are trying to maximize horizontal and vertical displacement within your jump. With the frontal plane, we have right jumps and left jumps. We're still focusing on bilateral. So using bilateral jump to the right or bilateral jump to the left. would be our frontal plane plyometrics. With a transverse plane, we are rotating right and rotating left. So leaving the ground and rotating our torso, rotating our hips to position ourselves towards the right or the left. Okay, so think of that as a 90-degree jump, a 180-degree jump, a 360-degree jump would be a transverse plane plyometric, especially if we're repeating those jumps. If we mix the sagittal and frontal plane, we could jump vertical and to the right, vertical and to the left. We can jump diagonally at different angles to maximize horizontal and lateral displacement. So maybe you're doing a 90-degree jump, a 45-degree jump, you're mixing and matching diagonal jumping patterns. We can add the frontal and the transverse plane together. So we could jump to the right plus with a right rotation, or jump to the right with a left rotation, jump to the left with a left rotation, things like that, where we are jumping and rotating. We're jumping to the side and rotating our body, and then having to reposition and land correctly while we've reoriented ourselves in different planes of motion. And then lastly, with our transverse and our sagittal plane together, we can jump vertical with right rotations, or we can jump horizontal with right or left rotations. We are mixing and matching and combining these planes. When we combine all three, we could say we could jump vertically and to the right, so a slight right displacement, maximizing vertical height, plus you're rotating to the right, or you're rotating to the left while you do this, or diagonal with left rotation. As we combine these, we see these movements look more and more similar to what we see within the sporting context, where we have to combine these dynamic movement patterns within multiple planes and do it safely and effectively. Okay, we can also use unilateral plyometrics, all of the same multiplanar variations, so our different directions of movement, planes of movement, apply to unilateral plyometrics, so that's with one leg. We can do a hop, which is one leg onto the same leg. We can use a skip, which is one leg onto the next leg that would then transition to the contralateral leg. So it's an individual small hop with a jump, and then a bound, which is contralateral limb landing. So you are moving from your right leg, landing on your left leg. Hops would be left, left, left. Skip would be left, left, right. It's just combining those patterns and combining those landing sequences. And then we have landing variations. We have bilateral landing variations. So we could do a 2 bounds into a bilateral land. We could do 2 bounds into an ipsilateral land, which would be a bound and then a skip. So then we're landing on the same side as we just took off. Or contralateral, where we're taking off bilaterally and landing on one leg, landing on the other leg, taking off on the right leg, landing and sticking on the left leg in a unilateral variation of the universal athletic position. So we can always combine and mix and match based on the needs of the sport, the needs of the athlete. And then we can start getting creative with our different tools. So you can do things that are pretty simple. So you can use targets or landing targets. So you can put a line on the ground. You can use tape. You can use hurdles, boxes, steps, cones, ropes. The tool doesn't really make the exercise. It's what the plyometric, and then the target gives you an ability to progress or regress what plyometric you're trying to do. A box, when you jump onto a box, you've minimized the impact from the landing. So you're landing, technically, from your peak, you're landing closer to your peak, so you're not accelerating as hard towards the ground, as opposed to a hurdle where you have to go to your peak and then come back all the way to the ground. But it also gives a cue for the athlete of how high they need to move and can force them to maybe produce greater force than they would consciously without that target. So use your targets based on what you need for changing your plyometric intensity. We can also over and underload our plyometric. So we can use something like a medicine ball to underload our plyometric, or use it as a way to add momentum to a lateral jump. I have some athletes doing this right now. They use a 6 to 8 pound medicine ball. They swing the medicine ball as they do a lateral jump so that they are almost underloading themselves. They're adding some momentum to their body, so they have to jump further and faster than they would without. Or we can do things with a barbell where we have overloading with our plyometrics. We can do repeated jumps with a barbell or a trap bar where they have to hold on to that barbell that's loaded, jump, rebound and absorb greater force than their own body weight, and repeat that jump again, adding some extra resistance so that they have to absorb greater levels of force and produce greater levels of force within a similar movement pattern that they would do within their sport. Okay, so lastly, some technical points that I want you to remember. Okay. Posterior chain is key to developing and absorbing force. That is where our power comes from, and our safety comes from, is from our glutes, our hamstrings, and our calves. That posterior chain is key to developing and absorbing force. The foot and the ankle complex and the hip complex control the knee and the frontal and transverse planes, especially when we are jumping and landing. Okay? Our foot and ankle have to be stable enough to interact with the ground and not collapse, as well as our hip needs to be strong enough to keep our thigh in line with our foot and ankles so that our knee stays in a safe position, because our knee is not made to internally and externally rotate or abduct and adduct like our hip and our ankle are able to do. So we have to be able to control that motion or resist the motion in the frontal and transverse planes of the thigh and the shin using the foot and the ankle and using the hip. So it's a stability issue there. The ankle must act like a stiff spring while the hip acts as a motor. Okay, so our ankle is a stiff spring that we are using to transfer the force from our hip motor. So our hip produces all of this force, all of this torque that we're trying to transfers through the knee. The knee allows us to transfer that force into the ankle, which is a stiff spring that explodes out of where we connect onto the ground. So it's a way to act as almost like a whip into the ground when we produce and when we absorb force. Okay. Our trunk posture needs to be rigid in order for us to transfer that force through our center of mass. If we do not keep a rigid trunk, we are losing force from our hip. So our hip tries to produce this force. It's producing it on the way down, but as it's transitioned up into our center of mass, if we are not bracing and creating a rigid trunk, we are going to lose energy through our torso. We're going to lessen the height or distance that we achieve within that jump. The contact time in a plyometric is dictated by your ability to produce power and the acceleration onto the ground. So the more power you can produce with your musculature, the shorter your ground to contact time can be. You will also extend your ground to contact time the higher your acceleration is towards the ground. So the higher the box you do a drop jump from, the longer your contact time is going to be. The more power you can produce, the more you can shorten that time. So if you're really trying to work on short ground contact time, you can't use high drop jumps. You have to use low drop jumps in order to minimize the acceleration just enough so that you can train the feeling of a short ground contact time. And lastly, our arm swing allows us to increase momentum, leading to increased height and distance in the direction of our projection of our jump. So we use our arms to increase the momentum so we can increase really the intensity and the distance, the height that we move our center of mass in our lower extremity plyometric exercises. Right, hopefully this helped clear up some of the understanding of what plyometrics are and give you some usable information to add to your training program with your athletes, with your clients, with yourself, and planning for your program design project. All right, thank you very much, and I'll see you later.